Welcome back for another deep dive. You ready to untangle something pretty interesting today?
Always.
Well, today, we're going to tackle conditional probability. Sounds a little intimidating, maybe,
It does have a kind of a complex ring to it.
but I promise it's super useful. And actually, once you get it, it's pretty intuitive.
Yeah.
It's all about, figuring out the chances of something happening.
Uh-huh.
But we already know some other piece of information.
Right.
So it's kind of like solving a puzzle.
Ooh, I like that analogy.
Yeah, and we have a really fun example in our source material to illustrate it. It involves something we all know and love, rolling dice.
Classic.
Yeah, but we're not just rolling it once, we're going to roll it twice.
Oh, interesting.
And this is a really cool way to kind of highlight the whole concept of a sample space.
Yeah. When you think about it, like when you roll a dice once, you've got those 6 sides, 6 possible outcomes,
Right.
all equally likely.
Right, but when you roll it twice, you've got to think about every single combination of those two rolls. So it's not just 6 possibilities anymore.
Oh, no, it explodes.
Yeah.
If you think about it visually, the source uses a table to map this out.
Yeah.
And there are 36 possible combinations.
Oh, wow.
It's amazing how those possibilities multiply so quickly.
Yeah, so it's like, let's say my first roll is a 3.
Okay.
That 3 could then branch out,
Mm-hmm.
right? Because the second roll could still be any of the other.
Exactly. Every single one.
1 to 6.
1 to 6, yep.
So that 1-3 is actually 6 different possibilities now.
It branches out, yeah.
And that's where this whole conditional probability thing comes in, right?
It does. So imagine we're told that the first roll is a 4.
Okay.
Everything changes, right?
Mm.
Our whole perspective shifts.
Ooh.
Yeah,
So now it's not just random chance anymore.
right.
We've got insider information. We've got a clue.
Exactly. That one piece of information, knowing the first roll is a 4, shrinks our sample space. We're no longer thinking about all 36.
Right.
We're just thinking about the ones where the first roll is a 4.
Okay, so now we've shrunk it from, 36 down to 6?
Exactly. Much smaller to work with.
Yeah. Wow. So that's what this conditional probability is all about.
It is. It's how the probability of an event changes when we know something has already happened.
Oh, that's a good way to put it.
Yeah, and the source even uses a special notation for this, which can be a little intimidating at first, but it's actually really helpful.
Okay.
It's P, open parenthesis, E, vertical bar, F, closed parenthesis.
Okay. Break that down for me a little bit.
Yeah, so it just means the probability of event E happening, given that event F has already occurred.
So in our dice example, F would be that first roll being a 4.
You got it. Perfect. Now let's get to a specific question that the source poses.
Okay.
What's the probability that the 2 dice rolls add up to 10, knowing that the first roll is a 4?
So it's not just any 2 numbers adding up to 10. It has to include that 4.
Exactly. We've got this restricted sample space now. We're only thinking about those outcomes where that first roll is a 4.
Okay, I'm following.
Now, how do we actually calculate this probability? Luckily, there's a handy formula that the source gives us.
Okay.
It's written like this. P, open parenthesis, E vertical bar F, close parenthesis equals P, open parenthesis, E and F, close parenthesis divided by P, open parenthesis, F, close parenthesis.
Oh, boy.
Yeah, I know. It looks a bit intimidating.
A lot of letters and symbols.
Let's unpack it. It's really not that bad.
Okay.
The top part, the P, open parenthesis, E and F, close parenthesis, that's the probability of both events happening.
So in this case, the 2 dice adding up to 10 and the first roll being a 4.
Exactly. And the bottom part, the P, open parenthesis, F, close parenthesis, is just the probability of that first roll being a 4.
Oh, okay.
And the source actually uses a Venn diagram to visualize this, which I always find helpful.
Oh, I love a good visual.
Me too. So we've got these 2 overlapping circles, right? One represents the sum being 10, and the other is the first roll being a 4.
Okay.
And the part where they overlap, that's the good stuff.
Yeah, where they both happen at the same time.
Exactly. That intersection is key for calculating our conditional probability.
All right, let's try to apply this formula to our dice problem.
Let's do it.
So we want to know the probability of the 2 rolls adding up to 10, but only if the first roll is a 4.
Right.
So we know rolling a 4 on that first roll is a 1 in 6 chance.
Oh, 1 out of 6, yep.
But of those 6 possibilities where the first roll is a 4, how many of them add up to 10?
That's the T question.
So a 4 and a 6.
Yes.
That's the only one, right?
That's it. Just 1.
So the probability of both things happening, that sum being 10 and the first roll being a 4, is just 1 out of 6.
Yes. 1 out of 6 or 1/6.
Okay. Now we can plug all of that into that formula.
We can. Are you ready?
I think so. Hit me.
Okay, so the probability of the sum being 10, given that the first roll is a 4, is open parenthesis, 1/6, close parenthesis, divided by, open parenthesis, 1/6, close parenthesis.
And that equals 1.
It does. It simplifies to
Well,
1.
that means it's like 100% chance.
Well, almost.
Almost.
It's important to remember this is within that restricted sample space where we know the first roll is a 4.
Right.
So it's not that we're guaranteed to roll a 10 every time we pick up the dice.
No, no, no.
But once we know that first roll is a 4,
Right.
the probability of getting a total of 10 becomes certain
Oh, I see.
within those specific possibilities.
Yeah.
It's a subtle but crucial distinction.
Okay.
It's not about absolute certainty,
Okay.
but about how our understanding of likelihood changes
Right.
based on new information.
So it's a 1 out of 6 chance
Yes.
that we'll roll a 10 if we already know the first one was a 4.
Exactly. You got it.
Wow.
Yeah.
It really is amazing how that one little piece of information can totally change the odds.
It really is.
Like before we knew it was a 4, it was 3 out of 36.
Uh-huh.
But now it's 1 out of 6.
Exactly. It's conditional on that first roll.
I think I'm starting to get it.
That's the power of conditional probability. It lets us adjust our understanding as we learn more.
Yeah, like finding a piece of a puzzle and suddenly seeing how a whole section fits together.
Exactly. And you know what? In the next part of our deep dive, we'll see how this seemingly simple concept plays out in real-life scenarios.
Oh, I can't wait.
Some of them might surprise you.
Awesome. Looking forward to it.
Me too. You know, one of the really cool things about conditional probability
Yeah.
is that sometimes it really challenges our intuition.
Oh, how so?
Like, especially when we're dealing with events that seem really rare
Okay.
or unlikely.
I'm intrigued. Give me an example.
Okay, so let's imagine this scenario from our source material.
Okay.
It has to do with medical testing.
Oh, okay.
So suppose there's this test for a rare disease,
Okay.
and it says it's like 99% accurate.
Wow, 99%. That's pretty good.
Yeah, you would think, right? You'd feel pretty confident.
I would, yeah.
But conditional probability actually shows us
Yeah.
that the actual likelihood of you having the disease, like given a positive test result,
Yeah.
might be way lower than 99%.
But how is it possible
Yeah.
if it's 99% accurate?
Right. It seems counterintuitive.
Yeah.
But it all comes down to how rare the disease is in the first place.
Okay.
So let's just say this disease affects only 1 in 10,000 people,
Okay.
right? So if we tested 10,000 people,
Yeah.
we'd statistically expect only one person to actually have the disease.
Right.
And since the test is 99% accurate, that person would probably test positive, right?
Yeah, that makes sense.
But here's the catch.
Okay.
Out of those other 9,999 people who don't have the disease,
Uh-huh.
the test would still incorrectly give a positive result for about 1% of them.
So there's still a chance you could get a positive even if you don't have it.
Exactly. And 1% of 9,999,
Yeah.
that's still about 100 people.
Wow. Okay, I see what you mean about counterintuitive.
Yeah, right. So even though the test is really accurate,
Yeah.
there's still this possibility of getting a false positive.
So it's not just about how good the test is.
Yeah.
It's about how common the disease is, too.
Yes, exactly.
Right.
And this is something called the base rate fallacy. It's kind of a fancy term.
The base rate fallacy?
Yeah, but all it really means is that we have to think about how common something is
Yeah.
when we're trying to figure out probabilities.
Okay, so back to the example.
Yeah.
You get a positive test result,
Uh-huh.
but your chances of actually having the disease are closer to 1 in 100,
Right.
not the 99% that the test said.
Exactly. Because of that base rate.
Wow, that's a huge difference.
It is. And this is really where conditional probability is so helpful
Yeah.
because it reminds us
Yeah.
that even really high probabilities can be misleading
Right.
if we don't look at the whole picture.
Don't just take things at face value, dig a little deeper. So are there other areas where, our intuition might kind of lead us astray like this?
Oh, all the time. Think about crime statistics, for example.
Okay, yeah.
If a neighborhood has a higher crime rate than another,
Yeah.
it doesn't automatically mean
Right.
that everyone living there is more likely to be a victim of crime.
Right. There could be other factors.
Exactly. So many other things to consider.
Okay.
Like, how old people are, their lifestyle choices,
Yeah.
personal safety practices.
So many things.
Yeah, it's complex.
So this conditional probability idea is really reminding us to not make big generalizations just based on statistics.
Yes, because probabilities, they always depend on the specific context.
Right.
And conditional probability really helps us see those nuances.
Like that saying, there are 3 kinds of lies.
Mm-hmm.
Lies, damned lies, and statistics.
Ooh, I like that one.
Yeah. So conditional probability is kind of helping us see past those misleading statistics.
It's a powerful tool.
It's empowering. Like now I feel a little more savvy. I'm not going to be swayed by, those crazy headlines.
That's great.
Or statistics that are taken out of context.
Exactly. You're thinking critically now.
So we've talked about how conditional probability can be counterintuitive, especially with those rare events. But are there any real-world applications where it's actually used to our advantage?
Oh, absolutely. Tons of them. I mean, conditional probability is a cornerstone of so many fields.
Like what?
Well, think about artificial intelligence, machine learning.
Oh, wow. Okay.
Finance, risk management.
High-level stuff.
It's used to predict stock prices, assess credit risk.
Wow.
Even personalize your recommendations on, streaming platforms.
It's everywhere. So it's not just a theoretical concept.
Not at all. It's shaping the world around us all the time.
Okay, I'm really interested in this machine learning thing.
Yeah.
Tell me more about that.
Okay, so in machine learning, algorithms use conditional probability to learn from data and then make predictions about the future.
So, if you're training an algorithm to recognize pictures of cats.
Exactly. Perfect example.
You feed it a bunch of pictures labeled cat and not cat.
Mm-hmm.
And it starts to learn, what are the features of a cat?
Right, like pointy ears, whiskers.
Yeah, exactly.
So the algorithm uses conditional probability
Okay.
to figure out how likely it is that an image contains a cat, given whether those certain features are present or not.
So, if it sees pointy ears, it's okay, this is probably a cat.
Probability's going up.
But if it doesn't see whiskers, it's maybe not.
Maybe not so much. Exactly.
Be constantly updating, learning.
Yes. All based on conditional probability.
This reminds me of those spam filters in email.
Ooh, yes. Another great example.
They probably use conditional probability to decide if a message is spam.
Absolutely. They analyze the words in the message, who sent it, all sorts of things.
It's crazy how this, seemingly simple concept is behind these powerful technologies.
It is. And the applications are just growing and growing.
That's amazing.
Yeah, it's really exciting.
Okay, so earlier you mentioned weather forecasting.
Mm-hmm.
Are they using this too, this conditional probability?
Oh, yeah, big time. Weather forecasting relies heavily on it.
How so?
Well, meteorologists use these really complex models that consider all sorts of variables like temperature, wind speed, humidity.
Wow, a lot of information.
And historical weather patterns, too.
So it's like a giant conditional probability problem.
You could say that.
Trying to figure out what's going to happen next.
Exactly. And they're constantly updating their predictions as new data comes in.
Right, because things are always changing.
And they adjust those probabilities based on the latest information.
Okay, so if I understand conditional probability better, maybe I'll be better at those strategy board games.
Ooh, interesting thought. Yeah, games with strategy and uncertainty.
Yeah.
Like poker, chess.
Yeah.
They really rely on assessing probabilities, making decisions when you don't have all the information.
So if I was good at conditional probability, maybe I could win at poker.
Well, it couldn't hurt.
Okay, this has been so eye-opening.
Good.
I'm starting to realize that conditional probability, it's not just about formulas.
It's a way of thinking.
Yeah. It's a whole new way of looking at the world.
Absolutely. It's about accepting that we don't have all the answers all the time.
Right.
It's about questioning our assumptions, being willing to update our beliefs as we get more information.
Embracing the complexity.
Yeah, exactly.
I'm definitely not intimidated by conditional probability anymore.
I'm glad.
In fact, I kind of want to go out and see it everywhere now.
That's the spirit.
Yeah.
Keep that curiosity alive.
So we've seen how this conditional probability can be a little counterintuitive.
Yeah.
And we've seen some of those real-world applications.
Uh-huh.
But the source also talks about how it can actually reveal hidden connections between events.
That's the fun part.
Okay, that definitely sounds intriguing.
It is, and it really ties back into this idea of independence. Oh.
When we talk about events being independent in probability, we mean that the outcome of one doesn't affect the outcome of the other.
Okay, yeah, so like flipping a coin.
Perfect example.
Heads on the first flip.
Yep.
Doesn't change what I'll get on the second.
Exactly. Each flip's independent.
Okay.
But sometimes we think things are independent, but when we look closer, they're not.
Okay, now I need an example. I'm not getting it.
So let's say we're looking at data on car accidents.
Okay.
Like our source mentions.
Yeah.
You might see a correlation between how old a driver is and how likely they are to be in an accident.
Yeah, that makes sense.
Right. Like younger drivers, maybe less experience.
Right, and older drivers, maybe slower reflexes.
Yeah, something like that.
Okay.
But what if we use this conditional probability idea and add in another piece of information?
Okay.
Like, what's the probability of an accident?
Yeah.
Given that the driver was speeding?
Ooh. Okay, so we're not just thinking about age anymore.
Exactly.
Yeah.
Now we're adding speeding into the mix.
Okay.
And what we might find is that once we take speeding into account, the age difference isn't as important.
Oh.
It could be that speeding is actually a much stronger predictor of accidents than age by itself.
So it's like, it's not just about one or the other.
Right.
They work together somehow.
They're connected in a way that we might not have seen at first.
Yeah. Conditional probability helps us see those connections.
It untangles those relationships.
Yeah. Okay, wow. This is making me think about all those correlations we see in the news.
All the time.
Or research, right. It's a good reminder that just because two things are correlated doesn't mean that one causes the other.
Correlation does not equal causation.
Right. Exactly. There could be those other factors like we were just talking about.
Lurking in the background. And conditional probability helps us tease all of that apart.
It gives us the tools to dig deeper.
I love that. Like a detective tool.
It is. We're like probability detectives.
Okay, so I'm really seeing now that this isn't just about like formulas and calculations.
It's a mindset.
It's a whole different way of thinking about the world.
Exactly. It's about recognizing that we don't always have the full picture.
Right.
It's being open to new information.
And being willing to change our minds when we learn something new.
Exactly. Embracing that uncertainty, the complexity of the world.
So we've really covered a lot of ground in this deep dive.
We have.
We started with, like, what is conditional probability? We saw how it can be counterintuitive sometimes.
Right.
And we looked at all those real-world examples.
From medical tests to AI to car accidents.
Yeah. So as we wrap up here, I'm just curious.
Yeah.
What's, like, the one big takeaway you hope our listeners walk away with?
That's a good question.
The big idea.
I think the biggest thing is just realizing that knowledge is power.
Oh, I like that.
The more we understand about the factors that are at play, the better decisions we can make.
It's like we have this secret decoder ring now.
I love that analogy.
For understanding the world.
Yes. So as you go about your day, just keep this idea in mind.
Yeah.
Think about how conditional probability might be playing a role in the choices you make, the things you read, the conversations you have.
It's everywhere.
It really is. You might be surprised.
Well, dear listener, we've come to the end of our deep dive.
It's been a journey.
Into conditional probability.
So much to explore.
We've only scratched the surface, but hopefully we've sparked your curiosity.
I hope so.
Given you a new way to think about the world.
Keep those minds open.
And all the information that's out there.
And keep exploring.
Until next time.